Otherwise, we're just gonna go forward. Okay. Okay. Hello, Zirva. How are you, my friend? Okay. So today we will basically start off with the new topic within this chapter, which is the law of conservation of linear momentum. So this definition will be of 2 marks, and the 2 marks are basically segregated like this. Number one. So you will start off with writing in an isolated system. Isolated system means that there are no unknown forces, but known forces only. Number two, the total momentum before a collision is equal to the total momentum after a collision. Yeah, right. So 1 mark for writing the first part and the other mark for this. What it really means is that if there is an object with a mass m1 and speed u1, and it collides with another mass m2 with the speed of u2. So this is what is happening before and after the collision. The first mass m1 goes with the speed of v1, and the other mass m2 goes with the speed v2. So the conservation of momentum would be the total momentum before must be equal to after, which means the general formula will be m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2, like that. All right. Now you will be applying this formula throughout the chapter, so you just need to use this right now and see what we do. Now we're gonna look at case one. In case one, you're gonna see two bodies collide and move away. So in this one, what's really happening is, suppose there is a body like this, which has mass m1 of 2 kilograms and u1 speed of 10 meters per second. Like that. Then you have another body, mass m2 of 5 kg speed, and u2 speed in the opposite direction as 20 meters per second, like this. After they collide, what happens is that this object goes in this direction with a speed v1 of 6 meters per second, and the other object we don't know where it goes, so we got to find that, like that. Okay. So now the first step is that because these are vector quantities, so you assign a sign, which means that if I'm taking this direction as positive on the right, negative on the left, so what will it do? So I'm going to solve this with this first. So in fact, let me write it here. So just write the formula first. M1 U1 plus M2 U2 equals M1 V1 plus M2 V2, like that. The mass 1 is 2 kilograms, speed is 10, the mass 2 is 5, and speed is negative 20. Why? Because all of these things I have taken positive, which are towards the right. I don't know about the last one, so I'm just gonna ignore that right now. Then in the next one, M1 is 2 and goes minus 6. M2 is 5, and that's V2. We do not know about that, so we will find out eventually. So this will be 20 minus 100 equals to minus 12 plus 5 V2. So then it will be minus 80 equals minus 12 plus 5 V2. Then you take 12 on the other side, it will be minus 68, 5 V2. Ultimately, you're going to get a negative 13.6 meters per second speed. Now, what you guys need to understand is that this negative sign, negative shows it moves to the left because we took left as negative. All right. If you guys have any questions here, please let me know. Abdullah, Ahmed, Asma, everything's clear?
Yes.
Caroline, Fan, Hibak, Shazib, Zain, Zirwa. Okay, good. Now, it doesn't really matter what direction you take. For example, somebody says, I want to take this direction as negative and this direction as positive. So will it change anything? I'd say no. The reason is when you write M1U1 plus M2U2, M1V1 plus M2V2. So then take 2 minus 10 plus 5, 20. This will give you 2 and 6 and 5V2. When you solve this, it's going to be minus 20 plus 100 equals to 12 plus V2. This will be 80 minus 12 equals to 5V2. 68 5V2. And V2 is going to be positive 13.6 meters per second squared. Sorry, meters per second. Now, this positive sign, according to our sign convention, means it moves to the left. Notice the final answer, to the left, doesn't change, because if you use the right signs, whatever sign is on the left and it moves to the left, it means that is going to show here. So it's as simple as this. Please let me know, have a look at it, and if you have any questions, I'd love to answer. Right. Okay, you guys just wait 1 minute. I just need a little bit of water. I'll be back. रखवा देना All right. So now, let's go to the next term. So in case 2, which is I think the most important, and most of the questions come from this. So two objects collide and they move together. Now, this word together has different synonyms that they use: stick, embed, and words like these. Okay. So, you guys need to remember this. Now, the moment you read these words, you should understand that this is case 2. For example, there is an object, say 2 kilograms. It's moving at 1.0 meters per second in this direction. There's another object which is 3 kilograms and it is moving with this speed in this direction. What happens is that before they collide, they look like this, and afterwards, they now combine together and now they're going at certain velocity. I don't know where, but this is how they stick together, right? So we're gonna look at it this way. So in this case, again, it's really up to you. It's gonna take a direction: positive, negative, and let's give them the directions. After that, we don't know. So just leave it as it is. Write the formula M1U1 plus M2U2 equals to M1V1 plus M2V2, like that. Now add your stuff, like 2, 1.0 plus 3, negative 4.0 equals to, when they combine afterwards, you got to add their masses because now they are just one body and they will move with the velocity v together. So this is the part which you guys need to understand, that masses are added up like that. Now, so let's solve this. This will be 2. This will be negative 12. This will be 5v. So negative 10 equals to 5. And then v is going to be negative 2 meters per second. So you already know that this means it is moving to the left. The two bodies, they combine and move to the left, like that. Okay. Let me know if you have a question here. Right. Okay. Now, the third case and the last one is case 3. And in that one, we'll say a stationary body recoils or explodes. Okay, so this is the case. Now, see what recoiling means. Suppose we got a cannon and it has a cannonball as well. So let me just copy this. The cannon itself, let's take it M1, 5000 kg. This is M2, which is 600 kilograms. The cannonball. Right now, they together they do not have speed. And after it has fired, the cannon would move backwards like that, and the cannonball would actually move forward like that. So now what do we do? Again, first of all, assign the signs: positive, negative. So this will be negative, that is going to be positive, because you already know if the ball is going to go forward, the cannon will go backward. That's why I'm just assigning the signs. Okay, use M1 U1, M2 U2, M1 V1 plus M2 V2. Initially, both of them have no speed, so momentum will be zero. Afterwards, M1, which is 5000, goes backwards safe with 5 meters per second, negative 5, plus this goes forward, which is 600 and V2. So you take it there, it's going to be 25,000 equals to 600 V2. So V2 will be 42 meters per second, like that. So you just need to remember that in a recoil system, if one object goes forward, the other object will go backward to conserve the momentum, because initial momentum is zero. Is it clear, everyone? Please have a look at it. Let me know if you understand. Caroline, everything is okay? Okay. Just write it down, please. I don't know why this isn't happening. Please let me shut down. Right. So now let's check it out. Huh? Anyway, okay. So the next thing we're gonna do is see how momentum, the law of conservation of momentum, basically never ever breaks. So let's talk about first a bomb going off. Now, you guys would want to help me in this. So let's suppose there is a bomb, looks like this, and right now it's ticking and it's on the ground like this. And when it basically goes off, this sharpnels, small particles of the bomb, move in all directions like that. Okay. So the momentum before the blast has to be zero because it's just ticking, there's no speed. What will be the momentum afterwards? Anybody can comment on this, please. Yes. Zirva, can you please tell me what will be the momentum afterwards? Yes, Zirva. Are you there? Zero. Why? Why would it be zero? Yes, Zirva. Why would it be zero? Anyone else who knows the answer for this? Asma, Ahmed Nawaz. Why would it be zero? Because they're moving at certain speeds. How is it possible it's zero? Yes, Ahmed. Abdullah, Zain, you can tell us, Hiba, Shazib, anyone. Okay, nobody knows. It is definitely going to be zero. And the reason is that basically the momentum is a vector quantity. So if you see in this direction, if this is positive, then this will be negative. Same goes for this direction, same goes for this direction. So every direction, when you add up all the momentum, because they're basically vector quantities, so they will end up canceling out each other, which means that the momentum afterwards is going to be zero. Is it clear, everyone? All right, very good. Then, now let's assume there are two people who are basically trying to play that tug of war, okay? Like that. So currently, in the tug of war, they have no momentum because they don't have momentum because they are stationary. One is pulling there, the other is pulling here. So momentum before is equal to zero. If the rope breaks, suppose, so it breaks from here, this person will start moving this way, this person will start moving this way. So what will be the momentum now? Yes, please. Okay. Yes, please. Momentum now. Hiba, can you please tell me the momentum? No idea. And Caroline, about you? Okay. And Zan, any idea what will be the momentum? The momentum is going to be zero. Why? Because when you add the momentum, again, the momentum of this person, if this is positive, this person will be negative. So when you add it up, the momentum has to be zero. So you guys need to understand the law cannot break. The whole system, if it had zero momentum initially, afterwards it would also have zero momentum. Now you need to think that how can it be zero? And it will be zero because after the rope breaks, they're going to move in the opposite directions, which means that one is positive, the other is negative. When you add them together, it will be zero. Is it clear, everyone? Okay. Now, the final example is of a rocket that is launched. So, suppose there is a rocket that is launched rocket like this. Like that. Initially, this is the rocket plus fuel, and it is stationary, so the momentum is zero. It's no, it's not moving. But when the rocket is launched, the rocket would move like this, and now it's expelling gases. It's going with the speed. Okay. What will be the momentum afterwards? Yes, please. Anyone who can tell me? If the initial momentum is zero, what will be the momentum afterwards? Any questions? Anything you want to say? Nobody has an answer? That's not fair. Ahmed Nawaz, Abdullah, you tell me, please. There has to be something. Not sure. Okay.
Zero.
Ahmed, your voice is too low. Can you please speak louder? All right.
Zero.
Zero. Now, that is true. It's going to be zero. Why? It's a question. Why? Why would it be zero? The reason why it is zero is because the rocket itself, oh my god, the rocket is going forward. So if it has a momentum m1v1 positive, the fuel is expelled outwards like this way in the opposite direction because it burns and it goes away, right? So the momentum is m2v2 and it is negative. So the momentum of the fuel basically pushes the rocket forward. And when you add them together, the momentum has to be zero. Is it clear, everyone? Abdullah, do you understand as well? Good. Please write this down. So, what I'm basically trying to teach you is no matter what happens, if they're talking about the system, the law of conservation of momentum cannot break. You could say the momentum of individual rocket or the fuel is changing. That's true. But if you look at both the rocket and the fuel together, whatever the momentum before was, it would be the same afterwards. So that's something you always need to stick on. Okay. All right. Write this down. Let me put on the charger and then we continue. Okay. Now, moving forward, The last thing we're going to do today is a small derivation, and this derivation is required and it may come in your exam as well. So please write the relationship between kinetic energy, we write, let's not be lazy, kinetic energy and momentum, like that. Now this derivation is required. So have a look. So first of all, we've learned in IGs that kinetic energy is given by half mv square. Now we also know that momentum is given by mass times velocity. Okay? So we can write kinetic energy is equal to half mv squared and momentum is mv. Notice that both have mv in them, but there's a square on v on the other one. So what do? We'll basically make v the subject. So when you do that, it's going to be p over m. Then take a square on both sides. When you take a square, it is going to be v square equals to p square over m square, like that. When you do that, you guys need to replace this value with this value. So when you replace, you're going to get kinetic energy equals to half m. Instead of v squared, just write p square over m square, like that. So there are two m's at the bottom, one at the top. You cancel them, and then ek will be equal to p square over 2m. That would be the relationship between kinetic energy and the momentum. Please write it down, and if you have any confusion how I did this, let me know. I can do it again. Very nice. So I think we're gonna stop here, and in tomorrow's class we'd continue and try to complete this chapter, okay? Which we will probably do it. So I will see you then. Have a nice day.